A Fermi level is the term used to describe the top of the collection of electrons energy levels at absolute zero temperature, and the highest energy level which electron can occupy the valency band at 0 Kelvin is called the Fermi level. Fermi level lies in the mid of the forbidden gap in intrinsic semiconductors. At 0 Kelvin, very high strengths are required to move an electron from the top of the valency band to the bottom of the conduction band. Conduction in intrinsic semiconductors. Under applied field, electrons thermally excited into the conduction band can move using the vacant sites in the conduction band. Holes move in opposite direction in the valency band. The conductivity of the semiconductor depends on the concentration of these charge carriers. Similar to drift velocity, electrons under the applied field in metal semiconductors, concept of mobility is used to calculate the conductivity. Mobility is nothing but drift velocity by the field velocity. Extrinsic semiconductors, the adding of doping elements in significance. Electrons in the conduction band are majority charge carriers. Law of mass action. P-type. Concentration loss in intrinsic and extrinsic semiconductors. Donor concentration, acceptor concentration. Temperature dependence of carrier concentration. Also, from the last equation about concentration, we note not only the Fermi level location changes when carrier concentration changes, but also the temperature changes when the carrier concentration changes, whether intrinsic or extrinsic conductors. Dependence of carrier concentration on temperature in intrinsic semiconductors, the relation is here proportional exponential. The transfer of current semiconductors or current in semiconductors. The current transfer of in semiconductor depends on two important factors, namely drift and diffusion. Drift, movement of charge carriers, which is due to the applied electric field. This movement is regular, which opposite of random Brownian motion. As we know, the holes always move in the direction of the electric field opposite to the electron's movement. This movement is called the drift. So the moment represented the drift velocity Vt and the drift coefficient called the mobility mu. Mobility for electron hole representative mu and mu p, also drift for the electron and hole respectively. V E is equals to mu E into E. Mu H is equals to mu H into E. What matters is factors: current density, drift, electrons, density of drift. There are the other two processes then drift and diffusion can occur: recombination and the generation process. The recombination, the process that electron recombining with the hole loses energy and move from the conduction band to valency band. The process that acquires energy to generate electron which moves from the valency band to the conduction band. Valency band to the conduction band, leaving free hole in the valency band, formation of electron hole pair. So the direct and indirect semiconductors of conduction and valence bands in energy momentum space. Because of the subject of recombination and generation, we should clarify that here there are two types of semiconductors, directly and indirectly. Okay, direct semiconductors. Junction. The Fermi level of semiconductor is higher than the metal, similar to the metal-metal junction. When the metal semiconductor junction is formed, the Fermi level must be line up at equilibrium.